Today's lesson's on number families. Number families is where we're going to understand and describe the relationships between number sets. So really, there's different labels for types of numbers that aren't just 1, 2, 3, 4, 5. Okay? Some very important vocabulary terms we need to know are natural numbers, whole numbers, integers, and rational numbers. So those are the four families that we're going to be talking about. Okay? Again, to some of you, this may be a review. To others, you may be hearing these terms for the first time. So if you know this, that's fine. Sit back, relax, enjoy, refresh your memory after that long summer. For those of you that this is new, let's get going. So it says, what is the name of the first set of numbers we learned about as kids? So think about if you have a younger brother or sister or a little cousin or yourself, when you were learning numbers with your parents or your grandma or whoever, what did they tell you to count? 1, 2, 3, 4, 5. So yesterday I was with my niece who's learning to count, and we counted spaghetti, how many pieces of spaghetti she has, and we had 5. So we would count 1, 2, 3, 4, 5. This is called natural numbers. So our first number family we've learned are natural numbers. Okay, natural being your first few numbers you've learned. Okay, some examples of this. Every time we talk about a number family, we have to use these awesome squiggly marks. Those squiggly marks are brackets that say we're talking about this specific set of numbers. So let's say again 1, 2, 3, 4, 5, and so on, all the way up to however many you want to go up to. How are whole numbers different than natural numbers? Now, whole numbers is a whole other set. So on top of learning your numbers, your natural numbers, 1, 2, 3, 4, 5, when you got a little older, you learned about this number 0. So you talked about, well, how many do I have now? And you look and you say, well, you have 0, right? Because you have nothing. So the only difference between whole numbers and natural numbers is that number 0. Okay, so the difference is whole numbers include 0. Then you continue onto the natural numbers. So our examples is we would now start at 0, 1, 2, 3, 4, and so on. Now if you notice, we have some numbers that are overlapping. The natural numbers and the whole numbers can be classified into two different families, okay? But 0 so far can only be classified under a whole number, and we'll get into that a little later. Then we're going to talk about integers. Integers is another family. What an integer is as you got a little older, we would talk about negative numbers. Okay, so we had 0, 1, 2, 3 with our whole numbers. We're going to use all of those numbers and their opposites, which means they're negative numbers. So we're going to take the whole number family and their opposites to make up the integer family. Okay, whole numbers and their opposites. So we're going to have a squiggly, okay, our bracket. And I'm going to start over here with 0, 1, 2, 3, and I'm going to move on. Now, what is 1's opposite? We would say it's negative 1. 2's opposite is negative 2. 3's opposite is negative 3. Okay, we're going to continue going all the way to the left as well. So integer are these whole numbers, 0, 1, 2, 3, and their opposites, -1, -2, -3, and so forth. The last number family we're going to talk about are rational numbers. A rational number is any fraction or whole number that is not being divided by 0. Is included into the rational numbers family. Okay, so the one word that's new in this is fraction. So this is including any positive number, negative number, whole number, or fraction. But any fraction can also be defined as a decimal as well. So some examples, we can say we have -1.25. We can have -3/4. We can still have 0. We can have 2. We can have 7/3, and so forth and so on. So any number really possible that's not being divided by 0. The only one that this can't be is if we had like 5/0. This is not a rational number because it is being divided by 0. So here's a nice little organizer that we can look at. It says, using the definitions of these number sets, let's fill in the graphic organizer. The smallest number set we have is our natural numbers. Again, that's what we talked about when we first started learning numbers. We learned 1, 2, 3, 4, and 5, and so on. The next one, we included the natural numbers, but we only added one number, and that one number was 0. And that's the whole number family. After that, we learned about negatives. So we took our natural numbers plus our 0, which is our whole, and then we added negatives. So now we have 3 sets of numbers. So we'd say -3, -2, -1, 0, 1, 2, and 3. So that's our integer family. And then we have our rational numbers. And that's any number that's not being divided by 0. So we would say 7/2, 1/2, 0, -2, and -1.5. Okay, any numbers that you can think of that, again, are not being divided by 0. So here I'm going to give you a couple numbers. I want you to use the word bank at the right to classify. Now remember we talked about those natural numbers are also whole numbers too, right? The only one in the whole number set that is not a natural number is 0. So, sorry about that. So if we look at number 9 can be classified as a natural number. That's one of those ones that you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I apologize. Natural numbers don't include 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But I just answered my own question. It is also a whole number. Okay, because we can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The only one that we can't say it is an integer, right? Because, oh, it is an integer. I'm being silly right now. It is an integer because it's the whole numbers and their opposites. And then it is also a rational number because it's not being divided by 0. For number 2, as soon as you see a negative, we know it cannot be a natural number or a whole number because those do not include negatives. The only 2 that include negatives are integers and rational numbers, so we would say C and D. The only time you could ever have a fraction in 4/5 is when you have a rational number. Remember, it's the only one that's a fraction or a whole number that is not being divided by 0. That's the definition. So we can only have one. It's not a natural number, it's not a whole number, it's not an integer. For 0, we do not start learning 0, 1, 2, 3. We start learning at 1. So it's not a natural number, but we can say it is whole, an integer, and a rational number. Okay, it's not being divided by 0. Again, the only time we have a decimal is when we have a rational number. So fractions and decimals can only be rational. Number 6, if we start all the way from 1 and count to a 101, we can have a natural number, a whole number, an integer, and a rational. Okay, so if you have a regular number, it's going to be all 4. Negative 1, though, remember, whenever we see a negative, it can only be C and D. Just a few more questions here. So if you are asked to write using complete sentences, please start your sentence with a capital letter, end with punctuation, and write out each word. We ask that you do not use text language. Like if you're writing your, it's not you are. Okay, you're writing actually your. We're not doing LOL. Come on. And no abbreviations. So we got to write things in complete sentences. So it says, given this set of rational numbers and whole numbers, which number set is contained within the other and why? What contained mean is like, which one can you fit inside of the other? Okay, so you have to ask yourself this, are all rational numbers whole numbers, or are all whole numbers rational numbers? And it helps to look at our chart we have here, because the smaller of the circles is contained in the larger. So notice how whole is smaller. So we would say our whole number set is contained within our rational number set. Because you can have whole numbers in the rational number set but you cannot have fractions within the whole number set. I know it seems like a lot, but just remember which one is the smaller one, and that's the one that's contained within. So given the set of integers and natural numbers, which is contained within the other and why? So we have integer and natural. So natural is the smaller one, so that one is contained within, because those are used within the integer, and not all of the integer numbers can be used in the natural. So we will just say, oops, the natural number set is contained within the integer number set. So I hope this helped. Again, if you are still struggling, our resource room is open every period, and it's in room 300. You do not need a pass. You can just walk in. Me and Mr. Arnold, if you have him, also are available in the morning or after school, so please just let us know when you need help. Otherwise, have a great day.